Welcome to the week one recording for Computer Fundamentals. And this recording actually covers all of the inside the PC unit. So it'll cover all the work that you have for this shortened, compressed 5-week computer applications course. So first thing I want to do, a couple reminders. If you haven't done the welcome and getting started work, you need to do that. That was the beginning of the week. My lesson recordings I'll have posted here, so you found this one already because you're watching it, obviously. Proper file names, read that. I've talked about that in the getting started recording. And then finally, here's the week one work. So for week one, so the beginning of the week, of course, you went through all of this. Some of you went down and did a couple of the quizzes for the second part of the week. But remember, what I try to do is break the week up into Tuesday, Thursday, and you can do this stuff any way you want. You might do all of this on Tuesday, Wednesday, then all of this down here on Thursday, Friday. Or you might do all this on Monday, Tuesday, and then all of this on Wednesday, Thursday, down below on Wednesday, Thursday. However you want to do it. But I just break it up to make it a little bit easier for you to schedule your work. So today we're going to go through all this stuff to help you with the inside the PC unit. All of this stuff down here. So I'm going to hit the minus sign. Of course, the first thing, what you're watching this recording now, and then you'll do the write-up. So I'll show you how the write-ups work, and I think you got a good feel for how the write-ups work when you did the getting started write-up at the beginning of the week. So here we go. So we are inside the PC. And I'm going to go ahead and take a quick look at the write-up. So you can see the write-up. This one is a fairly long one because there are lots of sections. So this one has 20 questions. So they're worth a point each. And remember on the write-ups, what you do, copy and paste everything into word processor. So you'd highlight all of that, paste it into a word processor. Then as you go through the recording, the lesson recording that you're watching now, when I come to an answer, pause the recording, then go into your word processor and answer the question. Answer the question directly below the individual questions, or answer it below each question. When you're finished, check your spelling and all of that stuff. Then finally, when you're finished with all this in the word processor with the answers, then you highlight the whole thing with the questions, answers, numbers, all of that. Then you paste in the Dropbox. Do not attach a file. So that's how these things work. Now, even though you don't attach a file, you should save this. I would save this as week one write-up in my Computer Fundamentals folder. Then if your computer powers down or something, you won't lose all of your work. But again, you don't attach a file. You just put all the text in the Dropbox. Okay, so in section 2, the questions, you're going to go to this site right here and tell me how Walt Disney used computers in 1939. What is the abbreviated name for the first generation computer? How big was it? How many people did it take to operate it? Who invented the first microprocessor and when? How is Moore's law related to computing speed? So we'll cover that stuff when we go through this unit. So this unit talks about the history of computing. And it talks a little bit about how technology has advanced. The first ball bearing in approximately 1500, microscope in 1608, and you can continue to move down here, and then the digital clock in 1956. But computers were right in the early 1900s. So when do you think the first computer was invented? So you can go right here to computer history on a timeline and take a look to see when the first computer was invented. So you can click on these different timelines and years or decades. And this is kind of interesting. You can see different computers that were developed in different decades. Or you can go look at different companies, people, things like that. So explore around that a little bit, see what you learn. I'm going to close that out. So in this section, we're going to explore the history of computers, compare and contrast different types of computers. So let's look at this. The first computer, or one of the first, was in 1946 called the ENIAC. That was the abbreviation. Electronic Numerical Integrator and Calculator. So it was a giant calculator, $500,000. Look, This is a whole room that it was in. A small apartment, weighed 30 tons, and this first general computer. It took 6 women, or 6 people, to operate this computer. It could do about 350 multiplications per second. Here's a little quiz. What do you think that your computer can do today? How many per second? Let's see. Today, your computer can do 1 billion multiplications per second, more than that. So it's considerably greater. I mean, a watch that you wear is 10 times more powerful than this computer. Your digital camera is probably 1,000 times more powerful than this computer. The Turing test. Computers in the future may weigh no more than 1.5 tons. A guy named Charles Turing said that. And of course, he wasn't thinking of things being miniaturized and microcomputers and different things like that. So it's really interesting how old-time thought wasn't modern. We weren't thinking to the future. So just think of things that we don't think about right now and the possibilities. So the invention of the microprocessor. So microprocessor was invented by the Intel Corporation in 1971, the first microprocessor. And the thing about the microprocessor is it has all kinds of circuit chips on it, transistors. Now these transistors used to be like the size of your finger, so that's why that ENIAC computer had to be so big. But then they miniaturized all those transistors and they could put them on this one microprocessor chip. So Intel invented it in 1971. That allowed everything to be miniaturized. And then the growth of the processor. Well, a guy named Moore, the number of transistors that can be placed on an integrated circuit is doubling every 2 years. So that's called Moore's law. So what it means is that technology is doubling every 2 years. So this just talked about number of transistors on an integrated circuit, but what that pertains to is that memory is doubling every year, computer speed is doubling every 2 years, etc. So that's what Moore's law is. So it really has to the idea that everything about technology is doubling every 2 years, and these days it's almost going faster than that. Here are a few different computers. First IBM ones, Commodore PET, some Tandy computers, Apple IIs. When I first got into computers, we had these Apple IIs in schools. PC clone war, meaning companies that make their computers like IBM PCs, which were the first computers. Of course, HP came out with computers, Compaq came out, Panasonic. Every technology company decided to come up with their own PC type computer. Then of course there's the Mac. So Macintosh, because Macintosh is a type of an apple, that you eat off a tree, but the Apple Computer Company, they named their computer Macintosh, so a type of an apple, right? So the great thing about the Apple is that it was the first graphical user interface. It had trash cans. You could dump files in trash cans and things like that, and then Windows copied what Apple was doing. Here's a little self-check about computers, see what you remember about that. A discussion, we skip all the discussions, but you can certainly think about these questions. Then finally the quiz. If you remember, I give quiz previews. So right here are all the quiz previews for Unit 1. So make sure you take advantage of those quiz previews to help you on your quizzes. So let's go back to the write-up, and we just covered all of this information. So you should have the answers to those. Okay, let's go into Section 3. So in Section 3, what is the motherboard? What does it contain? How are memory and storage different? One input device, one output device. So Section 3, the building blocks of a computer. So this would be your desktop computer. Now your laptop has the same stuff in it, but obviously not as much. It doesn't need as big as a fan, and some of the components are smaller, but that's what a desktop looks like. And many of you have probably taken computers apart and you know what they look like. So we're going to look at models and illustration to explore computer systems, demonstrate understanding of computer basics and technology concepts, look at the basic parts of computers and their functions. So the motherboard, if you open up a computer, the motherboard is what you see mostly. And the motherboard is the central body of the computer. It contains the microprocessor, the memory, and the key component. So the motherboard is the central body of the computer. So it holds everything, and the microprocessor is the brains of the computer. Now we have different components in a computer, and first one is memory. And memory in a computer allows calculations to happen. So the greater memory you have, then the greater processing speed your computer has, the greater processing power. So your memory might be like 2 gigabytes or 8 gigabytes or 4 gigabytes or something like that on your computer. And that, again, that's not how much information you can store in it, but that's how much power the computer has to operate, how many different calculations, because everything your computer does is essentially a calculation. So that's what memory is. And memory is stored in bytes. So if I have like 1 gigabyte, that's going to be a million bytes, or actually a billion bytes. So a kilobyte, of course, is 1,000 bytes. So you can go ahead and do this work to see if you can get those correct. Now, if you have a terabyte server, then that's a trillion bytes, so that's huge. Now, storage, so we talked about memory, which is the operating capacity of a computer. But now storage, this says, it talks about memory right here, 2 gigabytes of storage. But now storage is where all your files and everything get stored. So that's where storage and memory are different. So memory is what makes the computer operate more quickly. Storage is what allows you to save information on your computer. So that's how those two things are different. And my computer, I think, is 6 gigabytes of memory, which is called RAM, random access memory. But then my hard drive, I think, is about 400 gigabytes or something like that. Input and output. So input, of course, is how you get information in the computer. Output is how information comes out of the computer. So go through these things. I know you know most of those, and you should be able to figure out what almost all these things are. Taking a tour of your computer. So here's a video how stuff works. So go take a minute to watch that video, a few minutes. It's kind of interesting on how a computer processes information. Some study help. Here's some information with some computer gallery, glossary information, a little quiz to see how much you know about computers. So go mess around with those if you want to. And then the quiz. So the building blocks to the computer quiz, which will be right here, the section 3 quiz. Of course, as I said, the quiz previews are right up here. Okay, just back to the write-up. So here on the write-up, we answered all those questions, right? What is the motherboard and what does it contain? Memory and storage different. I talked about that. You're going to list one input device and one output device. Okay, section 4. How was information processed in the early years of computing? For a modern computer, what is the operating system considered? List 3 different operating systems. In what year did Windows become first popular? What are 2 of the most useful features of modern operating systems? So now we're in section 4, operating system. So operating systems. So the first computers, they were huge monoliths, meaning giant beings, giant things, and they had dedicated operators, or the people. Remember that ENIAC had 6 people that would operate it? But back in those days, what you'd do if a scientist wanted to run a program, they would put it onto these punch cards and then submit the program to the operator. The operator would feed them through to the computer, and then you come back later for the results. So that's how old-time computing was done. And then it advanced to magnetic tape, and sometimes you couldn't even get your answers for 1 or 2 days later. Now, when I was in college, we did punch cards, and this was in the mid-'70s or late '70s. And the biggest thing was it would take maybe like 10 or 12 punch cards just to do a simple multiplication problem. But if I was walking up the stairs of the computing building to turn in the punch cards and I dropped them, they weren't numbered. So I'd have to try to see if I get them right back in the right order. So then I'd turn in my stack of cards, and then it would have on the sign on the window, it would say, anything turned in by 1 o'clock today will be available after 3 o'clock tomorrow. Then I'd go back and they'd give me a printout of my results. So that was old-time computing. So in this section, we're going to look at operating systems, what it does, Windows XP specifically, understanding of problems with operating systems, benefits and drawbacks to Windows XP. So operating systems. So a computer needs an operating system. The operating system is the traffic controller or the decision maker for the computer. Now some operating systems, Windows is one of the most popular obviously, but there's Linux, Sun, Leopard, DOS are operating systems. And of course Apple has its own operating system. Here's some information. You can learn more about Windows, see if you can do that little quiz correctly. So operating system, why does a computer need one? So installing programs, locating files and all that, the operating system controls all of that. So that's the importance of the operating system. So the operating system controls what happens with the computer, how the computer operates, and those types of things. Now some common complaints about Windows is you have to upgrade your computer, it crashes a lot. Well, it certainly doesn't crash as much as it used to. Windows. Windows was introduced in 1985. I think I first used Windows probably in 1991. But really, Windows became most popular in 1990. So 1990 was when it really started to become popular. Then you can see the different iterations, the different version of Windows. My first Windows computer, I think it had Windows 3.0, I think is what I probably used first. But Windows became popular starting in 1990. And multitasking. So there are a couple of things that Windows is really useful for. First one is multitasking, which means doing more than one thing at once. So I could run multiple programs. Before Windows, with PC computers, you could only run one program at a time. Then you'd have to shut that program down to run another one. But multitasking is one main benefit of Windows computers. And plug and play is another main benefit. So these days with most Windows computers, all you have to do is just plug in your device, and the computer automatically does all of this stuff. It automatically loads things. Before plug and play, and even in early days of plug and play, you had to go in and actually program your computer to know how to make your printer work and things like that. So plug and play, and right before that multitasking, those are the two things that make Windows really useful. So discussion on operating systems, we don't do the discussions in this class, so don't worry about that. And then now you're to the quiz. So quiz, section 4 quiz right here, and the quiz previews right above. All right, so that was section 4. Let's go back to the write-up, and we'll take a look here. So it says section 4, how was information processed in the early years? So I talked about that, didn't I? Modern computer, what is the operating system considered? I talked about that. List 3 different operating systems. I showed you the list. What year did Windows become first popular? Talked about that. What are the two most useful features of modern operating systems? Talked about that. All right, section 5. 4 main items the Windows taskbar contains. In Windows, what does the scroll bar allow you to do? What is the most common drive letter for a computer's main hard drive? How are folders useful? What are the 2 common keys for computer shortcuts? So section 5. So in section 5, see, we're going to start talking about Windows XP. And Windows XP is the operating system. So in this section, we're going to explore the basics of Windows, demonstrate problem solving with XP, manipulate and control Windows desktop files and devices, identify common parts of a Windows application. So here we are in Windows, and this is explanation that talks about key terms and things like that. But some things to think about: the desktop, of course, is your entire screen. Then the taskbar, which is down at the bottom of your screen, it contains these 4 things. So the taskbar essentially contains these things. Now, it could have more. If you've added things to your taskbar, it would have more. But in general, those are the 4 things the taskbar contains. What you want to do is go ahead and click on this. The introduction is about 4 minutes. I'll talk about different parts of Windows. So the anatomy of a window, so you can see the different parts. The menu bar at the top telling you what program you're in. The toolbar, which gives you options for the program you're in. The scroll bars, and of course scroll bars allow you to move up and right, left, up and down, left and right. Then status bar means the status of your application. So this is if you're in like a word processing document. But a scroll bar is the easy way to move up and down, left or right on your screen. Different drive letters. The most common drive letter for your hard drive to store your information on your computer is usually drive C. Now A and B, some of your computers might have it, but that's where you used to have floppy disks. Now these days you might have like a DVD drive, you have the USB thumb drives and all that, and when you plug those into your computer, they end up getting their own drive letters. Sometimes printers have their own drive letters, but in general, drive C was the most common or the main storage drive on computers. Files and folders. So folder is a place for programs or data where you can put those. What I like to say is the thing about folders help you stay organized. So right here, folders help you keep things organized. I can't express that enough, to have the right types of folders so you'll know where everything is. So you should have been directed by your advisor or someone that you have a folder. You should put a folder on your computer called Computer Fundamentals A, and then within that folder you're going to save all the work you do in this class, and it's much easier to find. And to create folders, you just right click anywhere within, like on your desktop, and then you can create your new folder. Mouse action. So mice came in 1981, but they started using in 1965, and the first mouse I used was giant. It was bigger than my hand, and it had a giant roller ball on it. And then of course they turned it over to where the roller ball was rolling on the table, so the mouse could be quite a bit smaller. Keyboard shortcuts. Shortcuts are important because we just have 26 letters on our computer, but we want to use those letters to do different things. So there are different ways you can use shortcuts, and the two main shortcut keys, the Alt key, the ALT, and sometimes you can use Alt and then like the F keys on your computer. Like on my computer, Alt and then F8 will brighten my screen, or Alt F7 dims my screen, so you can see what I'm doing there. So that's holding down the ALT key and then doing the other keystroke. And that's called a keyboard combination. Then the Control S, that's to save. So if I hit Control S, and you can see it wants to save something here. Now, Control S I find very helpful because after once I initially save a program I'm working on, then all I have to do is just hit Control S after that, and it saves it automatically by that same name. Now you can go here and see more shortcuts, but the two main shortcut keys are the Alt key and the CTRL, the Control key. Those are the two main shortcuts because those two keys let you do many other things with other keystrokes on your computer. Okay, Windows Scavenger Hunt. So what you're going to do on this one, you're going to download this assignment document, and when you get that opened up, let me see if it opened here. Doesn't seem to want to open for me. That's not it. It doesn't seem to want to open for me, but in that document you'll go through and do a scavenger hunt on your computer, try to find some different information and such, and then you'll submit it into the Dropbox. And you can just copy and paste it as text in the Dropbox. You don't have to submit the document. Just copy and paste that in, that would be fine. So you're going to need to do that assignment. So let's go back to the write-up, and we're almost finished here. We're getting into section 6. So back to the write-up, scroll down a little bit. So what are the four main items the taskbar contains? I showed you that. What does the scroll bar allow you to do? Showed you that. Most common drive letter, talked about that. How are folders useful? And what are the two common keys used on Windows computers for shortcuts? I showed you that, the Alt and the Control key, right? Okay, section 6. What does more mobility mean to you? Discuss one possibility of technology in the area of digital health. What is one thing you would like a computer to do for you in the future? So let's go down to section 6, technology and the future. So this starts talking about how computer technology is going at a faster rate than any other science. For example, it takes 16 hours to go from Los Angeles to Singapore on a plane. That's essentially the same speed as 10 years ago. But computer technology has changed tremendously, hasn't it? Imagine if planes doubled their speed or possibilities every 2 years. Just like computing doubles every 2 years according to Moore's law. That'd be incredible, wouldn't it? So computer technology has outpaced everything else in our lives. We're going to look at current trends in technology and possibilities of the future with technology. So the current trends, multi-touch displays, of course, with this says iPhone, but certainly smartphones can be managed with your hands. This should say figures, I think. I should say figures. And then pens. So multi-touch is really important. So you can go watch a video about multi-touch here. And of course, in Minority Report movie and Iron Man, you've seen some real increases with technology. And here's information on a tabletop computer, a coffee table computer. Go take a look at that. It's pretty cool. And more mobility. So more computer mobility is a trend today. It probably won't be much longer before we have the data at our fingertips. And we really do that now, don't we, with smartphones? I mean, my son asked me, hey, Dad, what's the population of this country? I need it for my geography report. And he's sitting there with his smartphone, and I said, go look it up yourself. It's immediately right there, right? Now, what about some of the issues with more mobility where you can access stuff everywhere? It could be security, privacy, backup issues, data availability issues, right? So what I'd like you to do, we have that one Class Connect write-up question that talks about mobility. Talk about what it means to you. Is it a good thing? Is it a bad thing? What are some of the things that more mobility with technology can do for you? So list a couple of things. Digital health. So, doctor asks you, when's the last time that you this or that? So doctor, they have their own charts and things like that. Most of it's still on paper. But imagine if you had a computing device to where it reminds you when you need to take your next pill, or something that keeps track of your fitness. I mean, smartphones do that, right? You can download an app. And my son has it. He has this wristband, almost like a watch that he wears, and it logs all the things, the activities he does during the course of a day, and he gets points for it, and then automatically uploads to his smartphone, so then he can track the data. Computing device in your home that alerts families in case of an emergency. What about computer brains? Can we develop a brain through the use of computers that can think on its own? So the one question I have in the write-up talked about digital health, and you can discuss one of these ideas, or you can come up with your own idea about digital health. Biometrics. This is another thing technology is doing. Barcodes help stores keep track of their inventory. Barcodes, they're all individualized. But imagine what technology can do. Imagine if your refrigerator was smart enough that everything has a barcode in it, and your refrigerator could read everything in it. And some things are doing that, where you can, when you put food in the refrigerator reads it, and then the refrigerator will give you a menu of what you can make with the stuff that's in your refrigerator. Imagine if milk, if it could have a printout on the front of the refrigerator, a screen, that'll say, hey, your milk is going to go sour in 3 days. That'd be amazing, wouldn't it? Okay, last thing, future computers in the future. So this just talks about some old Quest statements that people made. Here a guy, Advanced Computing System Division of IBM, talked about the microchip. He said, well, what is it good for? That was in 1968. That's not that long ago. Here's somebody said the digital equipment. Ken Olsen said there's no reason anyone would want a computer in their home. That was in 1977. So can you imagine here at IBM in 1943? I think there's a world market for maybe 5 computers. So it's pretty amazing, isn't it? Right here, this person says data processing is a fad and won't last out the year of 1957. So that's some old-time thinking. But the one Class Connect write-up question is, what would you like a computer to be able to do for you in the future? And then finally, the unit exam is over here, and here's the unit exam preview. So that's the work for this week. So we've gone through all the write-up, I'm going to scroll down, and we answered all these write-up questions. We discussed those. So that's the write-up for this week. So you'll go through again on the write-ups, just to remind you, follow these directions up here. Copy and paste all of this into word processor. Find the answers through this recording. Write your answers directly below each item. Once you're finished, check your spelling and everything. And go ahead and save your file. Save it as inside the PC write-up. But then once you save it, all you'll do is just copy and paste everything into the Dropbox, text area of the Dropbox. You will not attach a file. So that's all we have for inside the PC for the week 1 write-up. And what I've done here is I've gone through all of this. We've discussed all of this. And week 1 is wrapped up. So I look forward to all your work coming in. Everybody keep working hard. Remember, only 5 weeks here, so week 1 is done. 20% of this course is finished already. So have a great week, everybody. I look forward to your work coming in. Bye.